All right, so we're going to look at 5.4, which is special cases. Okay. Can somebody tell me, when you draw two lines, what's one thing that could happen when you draw them? We already looked at a couple things today. Yeah? They could intersect in exactly one spot. Okay. And that would look something like this. Okay, so you have a spot on your, you need a little bigger? Right.
They can overlap.
Okay, you got a spot on your notes. Okay, to fill in what this is. This is one solution.
So they might need. You guys, and then copy what's above two, guys. What's underlined. You have where it says solutions of systems of linear equations. Write what's underlined as well.
So this is what Shannon just said. The lines cross one time. What would it look like if it was no solution? If the solution is where the lines cross, what would a picture of no solution look like? Josh? Parallel. So if we go to solve a solution, we draw the lines and they're parallel, they don't cross, no solution. Okay, so we've got one solution, we've got no solution, and the last case is infinitely many. How can two lines cross each other forever? If they're what? If they're the same line. Okay, that one's kind of hard to see, but pretend like you have two lines and you draw them right on top of each other. So this case, this is the one that we've been doing all along. Okay, this is just the normal case where you end up with one solution. No solution and infinite solutions. Those are special cases.
So guys, under one on your notes, you have lines across the top to write in each thing. One solution, no solution, infinitely many, and then you have spots on the bottom to write what's actually happening. So one solution, the lines are going to intersect at exactly one point. No solution, the lines are parallel. That means they go on forever and never cross. And then if the lines are exactly the same, and Mr. Hager said, they're going to be right on top of each other. So they're going to, every single point is going to be a solution. And then on the top, a system of linear equations can have one solution, no solution, or infinitely many.
Okay, now honestly, I don't think graphing them is the best way to do it. I think this is going to take the longest amount of time, okay, if we have to graph. So what we're going to do is when we solve them, we'll do a couple where we solve graphing, but then we're going to do some where we just do algebra. Okay, we already know what happens when we do algebra. That was that chart you guys had, all the different cases. Right? When you do elimination, you get x equals, you get a number. Y equals, you get a number. That's not going to happen when you have no solution or infinite solutions. When you go through your steps to solve it, something different is going to happen. It's not going to be kind of like, it's not going to be like the ones we did last week. Okay, so I don't think today we're really doing too many of these one solution problems. I don't think there's any. They're all special cases, I think. Okay. Does everybody have those three? Get those three cases? All right, so we're going to look at an example. We're going to try to solve it using algebra and then graphically. And then we'll give you guys another one to try with algebra and graphically, but then we're going to stop doing it both ways. We're just going to do one with algebra, one with a graph. Okay, so those are the four main examples. If we get to the fifth one, great.
Saying on the test, will we ask them to do, will there be a couple where they have to do both, solve algebraically and solve graphically?
They'll probably be separate problems.
Okay, separate.
Yeah.
Okay.
Yeah.
So Mr. Hager, they're going to kind of have to decide. If we ask them to solve algebraically, they can use elimination or they can use substitution, either one.
Yes.
But it's going to kind of look at how the equation is set up
Yep.
to see what method would be best.
So out of the two Mr. Roy just said, which one would you use here? Would you use elimination or would you use
Think
substitution?
about what we talked about in the warm-up.
Bay? Yeah, I would use substitution because there's already a letter isolated. There's already a letter by itself. So Bay, can you tell me what do you do with substitution?
You like, I think you plug one of the equations into the other one.
Exactly, you plug one of the equations into the other. So what you want to do is take the first equation. What letter is already by itself in the first equation? The y. And it says y equals, and I put a box around it. Okay. What's in that box is going to go right there. It says y equals 2x plus 1, so change the y to 2x plus 1. Okay, now I'll write that out. So Mimi, can you tell me what I write out after I do my substitution? 2x plus 1 equals 2x minus 5. Now we're going to solve it.
You guys, when they're both y equals, you're just setting them up equal to each other. Just set what's after the y equals. See, on the top one, what was after y equals was 2x plus 1. On the bottom one, what was after y equals was 2x minus 5. You have it set up like this. All you have to do is set what's after it up equal to each other.
Okay, next thing we want to do is get all our x's on the same side. So Kyle, do you want to take all the x's and move them to the right? Or do you want to move them to the left?
Right.
To the right. So how would you move this x to the other side? What would you do? Minus 2x. And where else? Yep. Minus it from here. Okay. What's going to happen on the left if you do 2x minus 2x? What does that leave you with on the left? 1. What about on the right? You have 2x minus 2x again. That cancels out, and you're left with negative 5. Do we have any letters left? No. If you run into an equation where your letters are all gone, you're done. Now we have to just look at that and write our answer. Okay? You can't do anything else with that. You ended up with 1 equals negative 5. So what do we think about that? 1 does not equal negative 5. That's not true, right? That's what we call, this is a false statement. Okay. False isn't the answer, though. That's just what this is called. This is a false statement. It's not true. It's false. So what do you think the answer is? No solution. Okay. If you end up with a false statement, that means no matter what you ever pick for x, you will never be able to solve this equation. It's impossible to make what's on the left equal what's on the right. And if you just think about it logically, you can't take a number and double it and then add 1. Take the same number, double it, and subtract 5, and never have the answer come out the same. If you double something and add 1, and you double the same thing and subtract 5, you're going to get different answers. You can never make the left and the right match. Okay? So that's what happens when you solve a no solution with algebra. That's exactly what happens every time. All right, let's look at solving it graphically. What are we already expecting to happen? It's going to be a no solution, and what does that? We're looking for parallel lines. So I'm just going to copy this so I can see it. Okay, can somebody tell me, how do I graph the top equation? What's my first step? Start at 1. Yep. We're going to go up to, and which way is over? Right. Up to, right 1. Up to, right 1. I usually try to do it at least twice so I get enough dots I can make a nice line. Yep, so draw your first line, probably about like that. It's a little bit off, but you get the idea. All right, first line. Can somebody else tell me how I start my second line? Where do I start? Antonio? Nope, not at 5. What's the y-intercept on that second equation? -5. That's not a +5, right? It's a -5. So you're going to start at -5. Aiden, then what?
And then what? And then we're gonna put it on the dot.
Okay, how do I figure out where my other dot goes?
Go up
Up how many?
2.
Up 2 and
Over to the, let's see, I'm looking at right.
so up 2, right 1. Marissa, can you summarize how we just did that? Why not?
Sure. Pay attention.
What did Aiden just say? So you don't even have to think about it. He just said how to do it. So what did he say? What did he say?
No recording just allowed.
Kaya, can you summarize what Aiden said?
Well, we got here, man.
Okay, what did he say?
So guys, like when I talk to the warm-up, when people aren't paying attention, like the side conversations, it doesn't work. And then people like at the end of the quarter, like last quarter, third quarter, people going around like, oh, how can I get my grade up? How can I do better on tests? Well, if you don't pay attention during the week and don't do what you need to do during the week, you can't expect like all of a sudden on Thursday or Friday, you're just gonna like, it's gonna click. Like, I didn't pay attention all week. I messed around in the back of the class. I talked to my friends. I mean, some of you guys can get away with it. Others of you can't. So by sitting there, poking people in the back, having a side conversation, like you're not helping yourself.
So somebody who either paid attention to how we just did the last equation or when Mr. Roy reviewed it for like 10 minutes, how do you graph a line? Which you know.
Okay, go up 2 and over 1 to the right.
And you go up 2 to the right 1 from where?
From the -5.
From the -5. So you start at your y-intercept. Put a dot there. And then a lot of times the way we showed you is to put that slope over 1 if you want to remember what the left and right is. It's right 1. So up 2, right 1. Okay. We're going to do that a couple times. We should have already known what's going to happen, right? The lines are parallel. You already know it's no solution. Okay? So it's got to be exactly the same as the other line, except it's just a little lower. Okay, so draw your line. Yes, they are parallel.
Oh, it is?
Yep. So if you solve graphically and get no solution, parallel lines. If you solve algebraically, you're going to get that false statement. Okay, we got, I think, 1 or 2 more graphs we'll look at today. Okay, any questions on how to graph a line? Before I randomly ask somebody. Yes.
Is there a way to tell like right off the bat it's going to be wrong?
Well, I can tell right off the bat just by looking at these equations, they're parallel because they have the same slope. So just by looking at these, I already know there's no solution. These numbers are the same. These numbers are different. Right away, that tells me no solution. Yep. Yeah, you can tell right away. All right, so Liam, can you remind us, how do we graph a line? What's the first thing we do? Yep, put a dot on the y-intercept. And then from there, what do you use to get your next dot? The slope, the number in front of x. Yep,
That's the X with it.
exactly. So you use your y-intercept and then you use your slope. Mr. Roy just talked about the directions. You either go up or you go down. But we always go to the right.
Yep. Even if that top, even if the number is negative.
Okay. Algebraically, I don't think this one's going to be too bad. I think graphically it's a harder problem. So now it's one step harder than what we just did. Why is this harder to do graphically?
Because
This is not in order.
there's,
What's the order you're looking for?
You're looking for
I know.
Yep, what's that pattern you're looking for?
You're supposed to be looking for y equals mx plus b.
Yes, so when we get to graphing, we're gonna have to rewrite it. Okay, but we don't have to worry about that yet. Three methods we've used: substitution, we're not doing graphing right now, or elimination. Which one here, substitution or elimination? Okay, why elimination? Yeah, you already set up x's in a column, y's in a column, numbers in a column. So, your first choice is you can pick. Really, I think you could do this one either way. Do you want to get rid of your x's, or do you want to get rid of your y's? All right, let me just copy these down. And negative 4x plus 2y equals 6. What letter did you say, y's? Thank you. All right, so we're going to get rid of the y's. That means you need same number, same letter, opposite sign. Okay, so focus on these. They're the same letter. Are they the same number?
No.
No. Are they the same sign? Same letter, say opposite signs. Are they opposite signs? No. So we need to fix this. What number would you need right there to combine with positive 2 and it would disappear? Negative 2. So what would you multiply everything in that equation by? Negative 2. Do you need to do anything to the bottom equation? Nope. So the bottom equation, I'm just going to copy it the way it is. Negative 4x plus 2y equals 6. I tried to kind of set it up like your template you used last week. We kind of did it horizontal, and then we worked down. Now let's do that. What's negative 2 times negative 2x? Positive what? 4x. What's negative 2 times y? Negative 2y. And what's negative 2 times 3? Negative 6. So yeah, what's negative 2y plus 2y? Gone. What about the x's? They also canceled out. Okay? We never had a problem where both the x's and the y's canceled at the same time. These are special cases. X's also cancel out. So what's on the left?
0.
Nothing. What about what's on the right? Negative 6 plus 6 is 0. Are all my letters gone? Okay, what did I say when all your letters are gone? What do you have to, do you have to keep doing more work? No. Letters are gone, you stop. You've got to look at your answer. What kind of statement is that? Look at it carefully. 0 equals 0.
False statement.
It's not a false.
0 does not equal 0?
Oh, no, it does. It's
It
a
does.
true statement.
This is true. Okay, this is different than the last one. This is a true statement. So what do you think that means our answer is?
Zero.
You only have 3 choices. One solution?
Many solutions.
What is it? Yeah.
Many.
Yeah, infinite solutions. Infinite solutions. How do you know it's infinite? You ended up with a true statement. So, before I even graph it, what does a graph of infinite solutions look like? Well, all lines keep going forever. It's the same line. So that means when I arrange this equation for y and that equation for y, I should get exactly the same equation twice. Let's see. So we have negative 2x plus y equals 3. What's my one step to get y by itself?
Oh, add y to 2x.
Well, y's okay. I don't want the x on the same side, though. We're going to add, not 2, 2x. And we're going to add 2x. On the left, that leaves me with just a y. What does it leave me with on the right? But I'd like it in the right order. Exactly, 2x
The
plus
X
3.
after the equal sign.
Now, when I rearrange the second equation, what am I expecting to get for the answer? Since it's an infinite solution, we should already know what the answer is going to be. The same thing. Okay, I should get the exact same thing again. So it's negative 4x plus 2y equals 6. Okay. How about Dominic? What's my first step here to get y by itself? Well, do you want to put the 2y with the 6, or do you want to get the 2y alone? So, first step, guys, when you have two terms and you want to get y by itself, you move the term with the x. That's what you put on the other side. So, how do you move that to the other side? You can't add 4 because you don't have a 4. You have a negative 4 with an x, so you've got to keep all that together. Add 4x. Yep. Okay, Hannah, what does that give me? Good. 2y equals, and she said 4x plus 6. I like the order she put that in. Now that doesn't look the same as what I have on the left. Yeah, we still didn't get y by itself. We've got to divide everything by 2. What's 2y divided by 2? Y.
Equals 2x plus 3.
And then 4 divided by 2 is 2. 6 divided by 2 is 3. Look what we got. The two equations we were solving are really the exact same thing. What does that mean again? If the two equations are the same line, which means how many solutions? No, one is when they cross infinite. All right, even though we already know it's infinite solutions, they said to graph it, we still have to graph it. Okay. Maggie, can you tell me how to graph this one? What's the first thing we do to graph? Okay, what's the y-intercept? No, that's the whole equation. So the y-intercept is just the plus 3. And then what do you do with that plus 3? How do I show that plus 3 on this picture? Yep, which way is positive 3? Up.
Remember on the y-axis, man. You don't freak out. You know how to do this stuff.
Okay, so up 3. And now, Derek, can you tell me what do I do to get another point? Somebody help Derek out? What do we do after we do that y-intercept? Ashley?
Go up 2 and over 1.
We go up 2. Which way is over?
Right.
Right. Okay. So next, use that slope. It's a positive 2 over a positive 1. Up 2 over 1. Do it a couple times. There's your line. Now, this time I don't even need to graph the other one. Okay, all you'd have to show me is what I just drew right there. Close enough. Okay? It's the same line twice. Okay, so those are the only two problems that we're going to do algebra and graphing. We got one more of each type. One algebra, one graph, and I think we'll probably get to the word problem.
And Ms. Hager, we did it that way just so they could see how it worked. Solving it algebraically and solving it graphically.
Yep.
As they could see. So guys, on the test, Ms. Hager, on the test, we would tell them solve it graphically or solve it algebraically.
Yes.
So guys, on the test, we're not going to make you, on the test, we wouldn't make you do both. Do one or the other. but if we ask you to solve it algebraically, you gotta determine. You could use, if I wanna solve it algebraically, one of two methods. What's one of the methods you could use? If you're gonna solve it algebraically, Shannon? Elimination is one. Or substitution, right? So what would be, what this one is called? What would be, what are we looking for if we're going to use, in the original setup, what would we look for to solve the elimination? How would the equation be set up if we're going to solve it with elimination? We talked about this in the warm-up too.
You have to,
How's your setup?
X plus Y and a number.
There you go. So x and y on the same side equals a number. What about if we're going to solve using substitution? Well, substitution and graphing would be set up the same way.
Y equals
Exactly. So, like Antonio just said, if I see y equals, all right, I know if it's y alone on the left-hand side of the equal sign, if it tells me to solve algebraically, what would I use? Substitution, right? I wouldn't use graphing because it's not asking me to solve graphing. All right? So we have one of two choices when I'm solving algebraically. Either elimination, so that means I want x and y on the same side, I'm going to use elimination, or I can solve using substitution. That means y is going to be alone on the left-hand side. So I only have two choices to solve algebraically. All right, so let's look at this. So for this one, Ariel, what do I want to use, elimination or substitution? Yeah, how come? Yeah, and x and y are on the same side, right? If it was y equals, I would use substitution. But x and y are on the same side.
Did you say
So,
substitution? I think you said substitution, right?
oh, did she?
Yes,
Yeah, but that's what, you could use substitution.
You could.
Elimination would be.
But what's going to happen? You're gonna have to move some stuff around if you want to solve using substitution. I thought you said elimination. I'm sorry.
I was so confused.
Ariel, I want to make you look good. That's all.
Don't
All right. So, I think Mr. Hager would agree with me. If it's set up like this, guys, x and y on the same side, I would use elimination because I don't have to rearrange the equation before I actually solve it. It's already set up the way I want. Now, which equation do you think we want to multiply? The top one or the bottom one? Emma, what do you think? Think we want to multiply the top one or the bottom one? Okay, we're going to multiply the top. What variable do you want to eliminate? You want to eliminate the y? We can do that. What are you going to multiply the top by to eliminate the y? -2. Good. So I want to multiply the top by -2, everything in it. Now, does anybody see another one? I could have eliminated the x. How could I have done that? Eliminated the x? That's like case 2 that we talked about last week. Yeah, I can multiply. It doesn't matter because I have a single x in both. I can multiply one of them, like Antonio just said, by a -1. All right? I can multiply one of these by a -1, but we can multiply the y's too. All right? Case 2 was we had a single variable in both. Case 3, we had a single variable in one only. So I'm going to multiply this by a -2. So I'm going to get -2x minus 2y equals -6. Right? Right, multiply this into everything. Oops, wrong way, Mr. Roy. This. I know. Chopped its head off. Didn't like it. All right, so that's, when I multiply everything by -2, that's what I get. Bottom, I didn't do anything to it. Just bring it over. Somebody remind me, what variable are we eliminating again? X or Y? Well, eliminated the Y. Right? Same number, same letter, different sign. Goodbye. What do I do now? Add the rest, right? Which way? Horizontally, vertically, up and down, right? So vertically. -2, -2x times x. What do I get? -x. All right? Equals, I'm going to get -2. All right? Good so far, Mr. Hager? All right? One more step, and I'll solve for x. Nini? Yeah, even though it's not written there, I know there's a negative 1 there. X is going to equal what, Nini? Give me a hint. Yeah, negative, negative, positive. X equals 2. So now, nothing happened. I didn't get a false statement here. I had x equals 2. That's okay. What do I have to do now? Once I get that x, Kyle, you want to go top or bottom? Bottom. We could have used either one, Kyle, because x is alone in both. All right. But Kyle said bottom one. I'm going to write it out. X plus 2y equals 4. I'm going to draw an arrow with this. I'm going to point it to x. 2 plus 2y equals 4. Next step will be what? Minus 2 on both sides, good Kyle? Minus 2, minus 2. 2y equals 2. One more step. Divide everything by 2.
Equal to 1.
And like Aiden just said, y equals 1. So this time, we got an actual solution. All right, we didn't get a whole bunch of numbers. We didn't get infinitely many. We didn't get no solution. We get a situation where if I graph this, what would it look like? What would happen to the lines? There's one solution. They would cross, right? They would intersect at 2, comma 1. All right, so you could have that situation where they intersect at one point. All right?
Let's do 5. Yeah,
do 5.
We're gonna. If we have time, we'll come back and do 4. But we did a couple. I think we already did 2
Yeah,
graphs.
maybe we'll do that one as at the end. Say, have them try that one and graph it.
Yeah. All right. First thing I just want to make sure people understand is that word, perimeter. What's perimeter mean? What about the outside? The color of it?
Yeah, the color of the outside.
Color of the outside.
The shape of the outside.
No,
Is
it's
it
the,
the area?
no,
Not area.
It's the length.
It's the length all around the shape, right? It's like if you had a fence around your yard and you added up how long each side was of the fence, that's the perimeter. So it says the perimeter of the trapezoid is 48.
Yeah, make sure it's.
Let me just write that.
I
Perimeter.
don't, if you want to draw the pictures, you can. You don't have to. So you don't have them on your notes, but you do have the problem. But I would definitely write down what Mr. Hager's writing.
So perimeter of trapezoid is 48. How about the perimeter of the rectangle? Yep, perimeter of rectangle equals 144. First, they want us to write a system. And then after we write it, we'll solve it. So let's look at just the perimeter. What did we say you do to find the perimeter of something? Add up all the outside edges. So Kyle, can you name all the outside edges in that trapezoid? And what are you going to do with all the things you just said? Add them. So the perimeter of the trapezoid is 2x plus 6y plus 4x plus 6y. And we already know what that's supposed to come out to. What's the perimeter of the trapezoid? 48. Okay, we'll come back to that in a second. What are the outside edges of the rectangle? About Ashley? 9x? What else? Another 9x? And another 18y. That's what makes it a rectangle. You have each side twice. And what are we going to do with all 4 of those things you just said to find the perimeter? We're going to add them up. So we're going to put 9x plus another 9x plus 18y plus another 18y. And what are they all going to add up to? We already know it's 144. Okay, is there anything I can do on the left-hand side of both equal signs? Kyle? Yeah, I got a bunch of like terms I can combine. What's 2x plus 4x? 6x. What about 6y and 6y? 12y. Now, does that look like the kind of equations some of the equations we've worked with today? All the x's and y's on the same side? Yeah. Now let's look at this one. What's 9x and 9x? 18x. What's 18y plus another 18y? Good, 36y. And that equals what? 144. Now, the two equations I have in boxes, are those set up to use elimination or substitution? Yeah, I would say elimination. And actually what I'm going to do is, I'm going to stack them vertically like we normally do. And now we have to decide what we would like to get rid of. Should we try to eliminate the x's or the y's?
The lower numbers. Let's work.
The lower numbers, okay. So still though, do you want to do x or y?
X.
All right, x. So we're going to work with the top equation because Aiden wants to work with the lower numbers. So what would this number have to turn into? It would have to turn into a negative 18. How
Times it by 4.
How can you turn that into a negative 18? Okay? Exactly. Multiply everything by negative 3. What about the bottom equation? Just leave it. So I get 18x plus 36y equals 144. What's negative 3 times 6x? What's negative 3 times 12y? Negative 3 times 12. Yep, negative 36y. And the last one's a little big. Let's use the calculator. 48 times negative 3, negative 144. What do you get when you add up your x's? 0? Not x, 0, they're gone.
Yeah.
What about when you add up the y's? That adds up to 0. So we have 0 on the left. What about on the right? What kind of statement is that?
It's infinite.
How many people think that's a false statement?
It's true.
It's true. So
It's infinite.
what does true mean? Aiden? Infinite solutions. It doesn't mean, infinite doesn't mean you can pick anything you want. Okay? Infinite means something like this. Two numbers that add up to 10. 1 and 9, 2 and 8, 3 and 7. There's infinitely many numbers that add up to 10, but you just can't pick any two numbers. You have to pick the right two. Okay? So in this problem, I don't know exactly what you'd have to pick for x and y, but there are infinitely many answers you could pick. You still have to find the right ones. Okay. So infinite solutions. Any questions on that? Okay, so the last one, we're going to put that one up and give you guys time to try it. Does that sound good, Mr. Roy? But just to end the video, I'm going to just put this at the end of the video. So the worksheet on 5.4 tonight, test on Thursday because there's no school, it's Good Friday. This is our first test for the term, probably the first test of 3. So we'll get three tests this term.
3 tests for the fourth quarter.
And then because we have the break and then you come back and it's shop week, we won't see you guys again until May 1st.
Yeah, next academic Monday is May 1st, which is...
Isn't it May 1st?
Yeah,
And then we get another 2 week break.
Yeah.
Memorial Day, that's the end of May. It's like a few weeks after that.
Hi, break it up.
All right, so you guys got about 8 minutes.
And guys, like Vanessa brings up a good point.